Okay, so we're going to examine the concepts of parametric and collinear. So we have a vector v in R2, that's 1, 2. If we add a fixed vector, x0, to each vector in the span of this non-zero vector v, we obtain the set x0 plus cv, where c is a scalar. So if we place this set in standard position, the heads represent points on the line which passes through x0 and is parallel to the span of v. So we denote this by saying the set L as x0 plus t times v, where t is a scalar in the real numbers, is a parametric representation of the line in Rn through x0 with direction v, and we call t the parameter. So for instance, in the example above, if we have x0 as the vector -2, 1, then L is the set -2, 1 plus t times 1, 2, where t is a scalar. So geometrically, if we add the vector 1, 2, or -2, 1, sorry, to v on all points in R2, we get something that looks like this, where this is x0, and we add v to every vector. So this is the line which passes through x0 and is parallel to the original vector v. So two non-zero vectors are collinear if one vector is a scalar multiple of the other. And actually this means both are actually scalar multiples of each other. So in general form, if v and w are vectors, and v is cw, where c does not equal 0, then v and w are collinear. We can also say that w is 1 over c times v. So for example, if v is 1, 2, and w is -3, -6, then since w is 3 times v, v and w are collinear. And the span of any two collinear vectors is a line.